Okay, now we're going to talk about yearly changes, and we need to talk about the seasons. And the first thing you need to understand is that sunlight, when it is coming straight down onto the ground or is coming in at a very perpendicular angle, that sunlight is going to be more concentrated. So this area is going to get hotter when the sun is directly overhead. Now, if the sunlight is coming in like this, then the energy of that sunlight is going to be spread out over a larger area. And so the ground is not going to get as hot. Also, another reason is that during the summer months, the sun is going to be above the horizon for a longer period of time, and so the earth is going to receive more energy from the sun during the summertime. Okay, so what has this got to do with the seasons? Okay, so that the earth is tilted at a 23-degree angle. Okay, so this is the spin axis of the earth, tilted at a 23. So if the sun is located over here, then that means that the light that is hitting in the northern hemisphere is going to be coming down at a more perpendicular angle. But the light that's coming in at the southern hemisphere is going to be hitting at a more of an angle. Okay, so that the southern hemisphere is going to be getting less energy from the sun. The northern hemisphere is going to be getting more energy from the sun. So this is going to be summertime. Okay, now the earth is going to orbit, so 6 months later the earth is going to be over here. It is still going to be tilted at that 23-degree angle. So now the sunlight is going to be hitting the southern horizon at a more perpendicular angle, and it's going to be more of a shallow angle when it's hitting the northern hemisphere up here. So the seasons are going to be reversed. So if it is summertime in the northern hemisphere, it's going to be winter time in the southern hemisphere and vice versa. Okay, what happens if your planet is tilted more? So Earth is tilted at a 23-degree angle. What would happen, first of all, if the Earth was not tilted? So if the Earth spun like this and was straight up and down, then all year round, the angle would be the same at the northern hemisphere and the southern hemisphere. So that in the northern, if the Earth was spinning like this and sunlight was coming in like this, then all year round it would be coming in at an angle and it would be cold in the northern hemisphere. At the equator, it would always be coming in perpendicular and it would be always hot at the equator. It would be coming in at an angle down here, and so it would always be cold at the southern hemisphere. So the seasons would not change. So you would always have the same temperatures at different latitudes. Okay, the more the Earth is tilted, the more severe the seasons are going to be. So the most severe seasons would occur if the Earth was tilted like this and was at a 90 degree, because then for a half a year the sunlight would be hitting this part of the Earth, and then this part over here would be in the deep freeze. Then 6 months later, this one would be getting all the sunlight, and then this part of the Earth would be in the deep freeze. So it depends on the tilt of the planet. And then the seasons are not, it's not a distance thing. So it is true that the Earth, as it goes around the sun, has an elliptical orbit, which means that sometimes the Earth is closer to the sun and sometimes it's further away. But if you were to look at that orbit, you would think it's a circle. It's very hard to see that it's stretched out into an ellipse. So the difference between when it's really close and when it's very far away is only about 3.9%. And so that's not enough to cause a drastic change in the seasons. So it's a tilt thing. That's what causes the seasons. Okay, then you also need to know about retrograde motion. And so retrograde motion, first of all, you cannot see it happen during the course of one night. So the idea is you're going to go out, you're going to look for a particular planet, and let's say that you see the planet, and at 10 o'clock in the evening, that planet is located right there. Okay, then you go out at 10 o'clock in the evening the next night, and you'll notice that it's not there, it's actually right about there. And then you go out the next night at 10 o'clock in the evening, you look for that planet, and you find that it's right here. So the starting position is changing. But if you keep watching it day after day after day for weeks, then you might notice that that this thing will start to go backwards, and then it will start to go forwards again. So when the planet is going backwards, that's called retrograde motion. Okay, and it has to do with as the Earth is passing in its orbit this planet, then it makes it appear that that planet is going backwards. It's an optical illusion. Or if this planet is passing us in our orbit, then it also looks like it's going backwards. So Mars has retrograde motion, but so does Venus. So they both do this retrograde motion thing. And it's an optical illusion caused as we are passing or being passed in our orbit by one of these planets. All right, so that finishes up this lesson. So let's take a break and we'll come back and we will review another lesson for the Unit 1 lecture exam.